Everyone, welcome to this lecture on CBOW, that is continuous back of words model, skip-gram model, and GloVe in natural language processing. So in this lecture, we are going to discuss when do you apply continuous back of words method, and when do you use the skip-gram model and GloVe representation for creating word embeddings. So we are going to discuss all these things in this lecture. So cbOW basically you used when you have a large data set and there may be more number of frequent words that may dominate the that may have an influence on the performance of the model. So in that case we apply this continuous back of words, and it basically takes the context of a word as input, and that should be a specific window size, and it predicts the target word. So it is most popular algorithm for learning word embeddings as part of this word to vect model. So for example, if you give the context words like the, cat, on, and sat for the target word mat, it will predict the target word as mat using these context words. And if we apply neural network for training the data, so you will observe that the model takes the context words, the input layer, and then it generates word vector representation. You will take an average or sum of those vectors to form a context vector, and then we are using the context vector as input to the fully connected layer or the dense layer. So where there is a softmax function to predict the probability distribution of the target word, and if the predicted output is having the maximum error, then it will minimize the error by applying a back propagation technique and stochastic descent optimization technique. So here averaging the context is one of the important aspect. It focuses on using the context words equally across the corpus, and here the order of the context words is not important. At the time of training the model, it adjusts the weights through the back propagation technique, and try to predict the correct target word based on the context words. And the speed of the algorithm, if you compare with the other method, so the speed of this algorithm is better compared to the skip-gram model, because it uses context word to predict one target word, whereas in skip-gram will use single target word to predict multiple words which are indicating the context awareness. And for example, here we have the sentence, the cat sat on the mat, and the window size is 2. So this model would predict 2 words before the before the target word sat, and 2 words after the target word sat. So here the context words are the, cat, on, the, and the predicted target word is sat. And in skip-gram, we give the input, the target word, and it predicts a set of context words. So for example, the word sat is given as input, and it predicts the context words like the, cat, on, and mat. And this is having an opposite function when you compare with the cbOW model, and this is suitable for smaller data sets where you may have more number of rare words. The rare words are less appearing across the corpus, and it makes multiple predictions for the given input target word. So it is somewhat slower than the cbOW model, and because it has to make multiple predictions, and the model has to adjust the weight to minimize the error between the predicted context words and the actual context words. So takes more time for training the model. If you give the sentence, for example, the cat sat on the mat, the target word is sat. So we consider the window size 1 here, and the output of the skip-gram model would be cat sat on these two words we have considered, one word before and one word after the target word. So the main difference is the CBOW model predicts the target word based on the context words. It is suitable for large corpus where you will be having more number of frequent words which will have the influence on the model. In skipgram, we give the target word as input, it predicts the context words as output, and it is suitable for small data sets where you will have more number of rare words, the words which are appearing less number of times across the corpus. In GloVe, we combine the benefits of CBOW and skipgram. It considers both local context and global context. We consider the co-occurrence matrix of words. We generate a co-occurrence matrix of words across a corpus. So this model learns word vectors through matrix factorization. The co-occurrence matrix is factorized into two matrices, one for the target words vector and another one for the context words vector. And for each entry in the matrix refers to how often word I co-occur with word J in a specific context. So there is a possibility that you may be having very less number of co-occurring terms, so it will have a sparse representation in the matrix. Let's now discuss the objective function of this GloVe model. So when we apply a factorization on this co-occurrence matrix X, we will be generating two matrices, sub-matrices, so one for the target words and another one for the context words vectors. So each entry would be denoted by ith row and jth column, and we train the model to minimize the weighted least square error. It reflects the weight reflects how frequently word occurs together. So the objective function is denoted by j and sum over I and jth column, the function of each entry, the function over each entry of the matrix xij, and we are taking the dot product of wi transpose and wj. So the word vector of ith row and jth column we are going to take, plus we are adding some bias terms to adjust the model's performance because the frequent words or rare words may have an influence on the model. In some data set you have less number of frequent words and more number of rare words. In some other data set you may have more number of rare words and less number of frequent words. So to adjust the weights we are using the bias terms, and the weighting function f of xij controls the co-occurrence counts, and we take the dot product between the word vectors to approximate the log of the co-occurrence probability. So sum of all these values will this function and this arithmetic and square of function will give the resultant value of GloVe. And the main purpose of introducing the bias term is to add a term to the word vector for each word I and j, so that it can consider the different words, how frequently that appears or rarely appears on the data set. So it captures interesting aspects. And for example, the frequent words like the, and, or, is, of may have a higher overall frequency in the corpus. So it may have an influence on the word vector representation. So if you introduce bias terms to adjust the model's probability, so it will shift the word vectors either up or down to adjust the word vectors representation. It will improve the performance of the model. It will improve the accuracy by reducing the overall error between the predicted and actual co-occurrence probabilities. The performance of the model will be improved. It will optimize the objective function, and also you can make the model more flexible to understand individual words characteristics. So the ultimate aim is to make the model make the model learn better from the word vector representation. So that's the ultimate aim. So it aims to achieve higher accuracy in generating word embeddings and learning word embeddings for each words. It, as mentioned earlier, it deals with rare words, common words, influence of these words in the model's performance. And so we generate two submatrices from the given matrix X. So the first matrix is representing the word vector representation of the target words, and the second matrix is representing the word vectors representation of the context words. So this GloVe model uses the dot product of the corresponding target vector representation and the context vectors, approximates the log of the co-occurrence count between these two vectors. So it captures interesting aspects, minimizing the difference between the actual co-occurrence data and the predicted co-occurrence data. So the key aspects of this GloVe technique is that it uses global statistics into consideration, and it is more efficient and scalable since we are applying matrix factorization. It can deal with large scale corpora and does not rely on the random sampling technique like a word to vector model. And considering embeddings, it considers resulting vectors that captures both syntactic relationships and semantic relationship between words. So which will be creating a more interesting and better representation which have similar meanings between words. And we consider the words like, for example, cat, dog, and pet. So if you take a pair of words, these pair of words will be having similar meanings and with a similar context. So these are given more importance, and will create such embeddings that considers the co-occurrence of these words. So in this lecture, you have learned the difference between CBOW, skip-gram, and GloVe. So CBOW predicts the target word for the given context words, and it is more efficient for large data set where you may have more number of frequent words, words appearing multiple times across the corpus, and it does not consider the word order as important characteristics in the data set. And whereas in skip-gram, it predicts the context words based on a target word. It works well for smaller data set. It works well for dealing with rare words which appear less number of times across a corpus. But it is more expensive, computationally expensive. GloVe model captures both syntactic relationship and semantic relationship based on co-occurrence of data. So considering pair of words, it checks the co-occurrence, and it considers the local context and global context, unlike the previous two models. So it combines advantages of both models. So when you are trying to prepare this technique for creating word representation, you should be specific to your application. So depending upon the requirements, you can apply this technique. Thank you all. So this is a task given to you. You can understand this problem first, analyze how cboww, skip-gram, and GloVe can be applied, and also discuss key principles of this. This is like a self exercise which you can do it. It will help you to understand better, as well as you can also take it as a assignment or simple project study. Thank you all.